Okay, now I am going to do what? All right, let's try this. I'm going to share my screen. I'm going to bring up my math lab. No, I'm not. Yeah, I am. No, I'm not.
I have a question.
Yes.
So on my math lab, is that an app, or do you have to go through the NWAC, the whole, like through the algebra icon?
I'm glad you mentioned that. You need, when you register, you need to be in Canvas. That's the way you get the discount.
Okay.
After that, you can use the username and the password that you created for my math lab, and you can go directly into my math lab. Just go to mymathlab.com, and you never have to go to Canvas again.
Okay, awesome. Thank you.
You're welcome. I'm looking at you down there, but you're not down there, you're up here. I know that. I'll get used to it. Okay. And let's bring up, see, where was I? Oh yeah, I'm going to Canvas. There, and click on my math lab. And no, I won't go to Assignment Manager. Instead, I'm going to click on this because it's just easier for me to find assignments. And here we are at assignments. And we're going to be talking about domain and range, which when you first learned about it in beginning algebra, Algebra 1, was really easy to figure out, and now it is less easy to figure out. So here, let me go there. All right, so here we are. Let me go to the first question. Again, these are videos that can help you. Okay. And what else? PowerPoint. Yes. Okay, and then also my calculator, just in case I need it. Of course I need it. I don't do that stuff in my head. Okay, and I'm going to clear that. So now, I know this is a really small picture right now, right?
Yes.
So I am going to shut down my camera temporarily. Go over here. Click on camera. And then minimize myself. Help, I'm shrinking. Can you see that? Can you see, is it bigger now?
It's the same.
It's still small?
I mean, it's normal.
You see, I want to know if I'm just a little picture down at the bottom, or if this is big enough for you to be able to see. I know when it's turned into a video, it's going to be big enough for you to see, but is it big enough for you to see right now?
Yes.
Yes. Yeah. Mm-hmm.
Okay, I really hope it is. I hope you're not just saying that because, sorry, what? Okay, I'm looking at some of your pictures down here. Can you see this okay? I mean, is it bigger now? Is it on the whole screen or is it just a little icon type thing?
It's not on the whole screen, and I cannot see it very well. I can see the figure, but I can't see the numbers if you begin to write.
Okay. What to do about that? I don't know.
Is it small?
Okay. If you hover your mouse over the Teams icon, you should see two pictures.
Mm-hmm.
Oh, and I should see two pictures. I see all of you. Hi.
Hi.
Okay, now that's all I see now. If I minimize you, then what I see is a whole screen of my MATLAB and PowerPoint. Now, is it PowerPoint that's real small, or which one of them is small?
It's not a full screen on my end. And
They're both almost full.
Say it again. I'm sorry, I didn't hear.
It's not a full screen on my end. And they're both equal sizes, which is small for me.
Okay. Is it a full screen for anyone?
It's fine. I mean,
fine
yeah,
for
it's a
me.
full screen. It's a split between the PowerPoint and the homework.
Yeah, I can. Yeah, same here.
It's fine for me.
Me too.
I'm concerned it's not really fine. But it's going to have to do for today, and I'll try to find a better way to do it next time.
Sounds fair.
Okay. So here we go. Can you see what's on my MATLAB right now? We're going to be talking about domain and range. Okay. One of the best examples of domain is you have a bunch of points, like the point 2, 3. Can everybody see me write 2, 3? Okay.
Yeah.
Yes.
Okay. And you have the point -5, 7. And you have the point 8, 2. Now we could graph these if we wanted to, but those are, I mean, plot the 3 points separately. But these are just 3 miscellaneous points that we've decided to look at the same time. So I put these squiggles around them, which means that we're now talking about them as a group, as a set. Okay, the x coordinates are 2, -5, and 8. And the y coordinates are 3, 7, and 2. So the simplest example of what domain is and what range is this, that the domain is going to be the set just containing the x coordinates, but not the y coordinates. So 2, -5, and 8. You don't have to put those in order if you don't want to. And the range consists of all the y coordinates, 3, 7, and 2. And again, you don't have to put them in order unless you want to. Now that is basically what domain and range are. But now it starts to get complicated. So here we are. Here's a picture, a graph. And we're being asked about this graph. Okay, and we're going to be asked several questions about this. The first thing we're being asked is looking at this graph on number 1 in 2.3. Looking at this graph, it wants to know what f of 1 is. That would be easy if we had a formula for the function, but we don't. All we have is a drawing. But this is to help us learn, help you learn what functions really are. What they do is they take a number from the x-axis and they move it to the y-axis. So what's going to happen here is f of 1, here's 1 right here. Do you see my mouse hitting number 1 on the x-axis?
Yes.
Okay, good. The reason I keep asking is I'm just unsure what you're able to see. All right, what the function does, this graph is the actual function. And what it does is it pulls up this 1 from the x-axis. And then where, I go up from the x-axis and I finally touch where the graph is. And then I head over to the y-axis and it lands me at 2. So, stop that. F of 1 is 2. This number is always the y coordinate. This number in the parentheses is always the x coordinate. So what we're talking about here is the point 1, 2, which is what this point is right there. It's the point 1, 2. So I kind of think of it, I have a very vivid imagination. I think of it as this UFO that's hovering over the ground and it sees me. Oh gosh. And it sucks me up to the UFO and it spits me over to its planet right there. Kind of, I'm sure there's a more positive way to look at it, but that's what functions do. So I am going to go over here and click on 2.
I think I'm missing something. Where did you get the 2.3?
Oh, I'm sorry. Do you see, this is problem number 2.3.3. That's
Oh,
its
okay.
code. So actually, if you were doing homework in the book, you would go to section 2.3 and then do problem number 3 in the book.
Oh, okay.
They correlate with each other that way. But that also is how I know what section we're in, is I look at the first 2 numbers there.
Okay. And where did you get the, okay, F1, is there an F? Like, how did you, oh, because it's a Y, it's on the x-axis, right?
Yeah, the 1 is on the x-axis.
So there, okay.
And so I followed it up to the graph and
Okay.
then went over to the y-axis, and that's where I got the 2.
Okay, gotcha. Okay.
Can you see this okay over here?
Yes, I can, yes.
Okay, good. Now, these meanies are asking us something else. Let's see what it is. Good job, I like that. Now, let's talk about what makes this difficult. It's asking us for the domain of this. We've got an open circle down here and an open circle up here. Now, if these circles were colored in, then this would be the point, let's see, -1, -2, -3, and down to -1. So the left point would be -3, -1, And then over on the far right side, if that point were solid, if it were colored in, then this point would be 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So that would be the point 5, 5. Okay, and your function is this graph right here. So if we were to pretend for a moment that we have something like this, and these points are colored in, we would be going from the point -3, -1, to the point 5, 5. Can you see that okay? Or is it too small?
I could see
I
it.
can see it.
Is there anyone who can't see it? Because I'll just keep playing with it. What, Control plus and see if that works? No, okay. All right, well, anyway, we're being asked, well, what is the domain of this thing? Well, to find the domain, you look at the x coordinates of the end point. On the left, you have a -3. And on the right, you have a +5. And if we were using something called interval notation, here, we don't really need this now that we have this. If we were using interval notation, which is what you've used up to now, if these points were solid, you would write, okay, this is what you would write. You would say, okay, for the domain, because I have an infinite number of points that are infinitely close together, I would put a bracket and a -3 on the left, and a 5 and a bracket on the right. And that would be if what I was looking at was this. Now, the thing is, that's not what we're looking at. Oh, I did start again. Okay, great. Excuse me, sorry. What we're looking at, we don't have these solid points, do we? No, we don't. Instead, we have open points like this.
Miss Barbara, I cannot see your screen.
I lost you too.
Yeah, your screen's
Oh, okay, thank you for telling me. That was a plain teacher moan. Now I know not to do what I did. Okay, I am going to try to do this again. Nope, that didn't work. Okay, then I'm going to go through the process again. I turn on my Teams camera. It just took over. Now I'm going to share my screen. I'm going to go to whole screen.
There it is.
There you go.
It's not big right now though, right?
Yes,
It's
it is.
small.
It looks fine.
Yeah.
Are you sure?
Yes.
I mean, it's not like real little down at the bottom.
No.
No.
Oh, You tell me if it gets that way. Okay, so back to this. These open circles are like ghosts. It means that the very end points aren't there, but the line gets so close to them, we say it gets infinitely close. But I can't use this notation anymore. I can't use a bracket anymore and a bracket because that would say that those holes were colored in, that they were solid. Instead, they're open. So I have to pull up my eraser. I have to get rid of that and that, and instead put in parentheses. Whoop, nope. Now put in parentheses. And this would be my answer in interval notation to what the domain of this is. It goes from almost all the way to -3 to almost all the way to +5 on the x-axis because the domain is always on the x-axis.
So the interval notation is open circles.
Open parenthesis. Well, yeah, you've got a parenthesis. We don't use a bracket unless the holes are closed.
Is that still called interval notation?
Yes, it would still be. This is still interval notation. It's just a different kind of notation.
Oh, okay.
Okay, now, we're not looking at that though. We're not looking at interval notation. My math lab has just thrown this at us because in college algebra, you start learning, let me get a new slide, set builder notation.
I don't understand.
I know. Just got to take a lot of stuff on faith. A lot of it has to do with a way of writing. Okay, set builder notation. Interval notation, let me write this down here because that's the way we wrote it before. Interval notation, which I like better incidentally. Nobody asked me though. Is this -3 on the left, +5 on the right, but not really -3 and not really 5, just really, really close to them. Now, we have to choose one of these answers as being saying the same thing in set builder notation. So here we go. This says we're dealing with domain. We're on the x-axis. And then we describe what the x's are that we're talking about, namely that we've got -3 on the left and +5 on the right, and x is between them. And when you've got open circles like this, you're going to use what are called strict inequalities. Let me write this better. That -3 is to the left of whatever x might be, and that's to the left of 5. These two ways of writing say exactly the same thing, exactly, but they're just two different ways of writing. The value of this is you don't have to use the word domain because the range would never be an x. The range can only be a y. So the x's are always going to be domain values. Here, on the other hand, if I'm writing domain, I have to actually write the word domain, or DOM, which is the abbreviation for domain. Now you'll get used to this as we move along. You've already dealt with inequalities, where inequalities mean less than or to the left of. Notice we always have arrows pointing to the left up here. X is in between -3 and 5, but not touching -3 and 5. So I am going to go here to A, and I'm going to click on A. And I'm going to check my answer. And it tells me I'm right. Right now, what are the X values such that f of X equals 2? It's gone back to, again, what is a function? Now we're looking at a completely different question, actually. F of X equals 2. Remember, this is always the X, and you can tell it's an X because it says X. This is always a Y. So what they're asking here is, what X's pair up with Y equals 2? Well, we've actually already answered the other side of that. Here's 2 on the Y-axis. I go over to the graph. When I hit the graph, I head down toward the X-axis, and I hit the number 1. So Y is 2 when X equals 1. And so our answer is just going to be, hey, it's the number 1. What value of X, what X values are such that f of X, f of 1, equals 2? So I hit 1. Okay, this is just going the other way from this. Here they say, what is Y when X equals 1? And we found out it was 2. When X is 1, Y is 2. Now they're saying, okay, if Y equals 2, what is X? So you start at the Y, go to the graph, come down, and see that you're at 1.
Miss Barbara, so you use like that line to guide you to?
Yes, exactly.
Okay.
Exactly.
Okay.
That's exactly what I'm doing because I don't have the function. I don't have the formula. I have to go by the graph.
All right.
Good question.
Thank you.
Okay, now I'm going to hit final check. I always get nervous when they have final check. All right, here's the last question. They're asking about the range. Well, just like the domain is on the x-axis, the range is on the y-axis. So it goes from the lowest point to the highest point. So let's come over here and look at what range would be. If I had this, where this was -3, -1, and this was 5, and I forget what that is, 5, 5. It was the end points of the x coordinates that gave us the domain, both here and here. But of course, I mean, we have these filled in holes right now. So I just wanted to show you if the holes were filled in. Our domain Let's go to another slide. So I'll have this, and I'll have this, and I'll have -3, -1, and 5, 5. If we were doing interval notation, the domain would be bracket -3, 5, bracket. The range is on the y-axis, so you look at the y coordinates. Our range would be from the lowest to the highest. Bracket -1, 5. Because the y coordinate is also a 5 up there. Now, when you have open holes like this, the domain is going to be parenthesis -3, 5 parenthesis, and the range is going to be -1, 5, like that. And that's if you're using interval notation. Now I'm going to go to another slide. I made myself a whole lot of slides here, so I wouldn't have to stop and make a new one. Okay, now here we go back. If we have this, and we're using set builder notation, okay, we would do this. This isn't a 1, this is a bar, a vertical bar going up and down. It separates. And for the domain, so this would be the domain. And the range would be this. So the domain we know would go, the x's go from -3, x is in the middle, to +5, because the x coordinate here is 5. The domain is going to go from that -1 to this 5 right here. -1. Now it's y that's in the middle. And we have different ways of writing things because math comes from all over the world. And so maybe the people in Russia wrote it differently from the people in Germany or the people in England. But you could also write it out in words, but the problem is you would have to use a lot of words. Let's try it again on another one. Oops, I didn't choose it, did I? -1 to 5, -1 to 5, there it is. -1 to 5 with the y's in the middle. That is y equals -1 is on the bottom. Y equals 5 is at the top. And all of these y's, well, all of these y's between -1 and 5 are the y's that are going to be in the range. Okay, let's look at another one. Oh, I have not completed. Sorry. But that's good to know. Check answer. Yes.
It's not just picking up the look in the mirror.
Now let's look at this one.
Yeah,
The complication with this is that, look at this. It goes forever up and down, but it also goes forever to the left. This is going to slope slowly out to the left, and this is going to slope slowly out to the right, just as it's going down quickly and up quickly. And there's no limit. Look at that. Those arrows mean it's just going to keep going and going and going. Okay, so the first question we're being asked here is, what is f of -2? Well, that's easy enough. I'll just find that. I don't even have to know for sure. All I have to do is start at -2 on the x-axis. So I'm going to go out to -1, -2, right there. That's all I have to do. Then come down to the graph. Whoop. Okay, that's where I start. Stop, rather.
Did anybody else's freeze?
Okay, if your screen is
No.
if your
Okay.
screen is freezing, you might want to restart your computer. Actually, restart it.
Okay.
Okay, and so at -2, we came down here to the graph. And once we're there, the graph stops us. So we go over to the y-axis and we find out that y is -4. So I would type a -4 here. -4. And then I check my answer. And it tells me, good, okay. And now we've got to deal with this again. Oh my goodness, what is all this? Well, this is what it is. There's something they're not telling you because they figure you already know it, only it's easy to forget. I also have to find a way to make that white page bigger. But I'll do that before next time, or use a different, maybe I'll use Word next time. But consider any graph. Well, they're not going to look like that. All right, I have a ruler. Ah! Okay, I'll have to find out how to use the ruler too. All right, go away. All right. So we're just going to have to accept this. All right, here's my best as I can. Oh, y-axis. And here's the best I can do with the x-axis. And you've got all your positive x's here. You've got your negative x's here. You've got your positive y's here. You've got your negative y's here. You've got 0, 0 in the middle. And then what? These x's go forever to the right. That's positive infinity. These x's go forever to the left. This is negative infinity. These y's go forever down. That's negative infinity. And these y's go forever up. That's positive infinity. So with the domain, with this particular graph, since you're going to go forever to the right, that means it's going to go to positive, the graph is going to go to positive infinity on the x-axis. This goes, whoa, this goes forever to the left. I can move it around? Wild. This goes forever to the left. And you've got negative infinity over here. That's the symbol of forever to the left. So this graph, if we try to not think about the up and down motion, but just the left and the right motion, the domain is going to go from, we always say it goes from left to right. The domain is going to be from negative infinity on the left to positive infinity on the right. And that means you would have the right to expect, if you had interval notation, and we were drawing this, which incidentally, well, never mind. This is the graph of something to the x to the third power, but I don't know what. For the domain, if you were in interval notation, this is what you would write. You never put parentheses around infinity signs. Now, in set builder notation, the domain is going to look like, well, they write it differently. No, it's this. It's all real numbers. Often you see x such that x is all real numbers. Are there unreal numbers? Yes, but we haven't gotten there yet. Well, actually, you did in intermediate algebra, in algebra 2, but that may have been a long time ago. But only real numbers live on the x-axis and the y-axis. It's really important that you get that in there, okay? So I'm going to check and see if they like B. Fantastic. All right. So X is all real numbers. Now they want us to find, okay, what are the X values that go with Y equals -1? I don't know. Let's find it. I go to the graph. I come down to Y equals -1. I go over to the graph. Well, I come to the axes. I go to Y equals -1. I come over to the graph. That stops me, so I have to start going up. Well, that's X equals -1. So the X that goes with Y equals -1 is X equals -1. So I'm going to click.
Miss Barbara,
Yeah.
did you use the x-axis or the y-axis to guide you?
Very good. This number over here on the right, I'll write it bigger here. Well, I'll try to write it bigger. F of X equals -1. This is the Y number over here. This is the X number over here. So when you have a number over here, what they're asking is, okay, Y is -1, but what is X?
Oh, okay.
Okay, so I have to actually start at -1 and then go over to the graph. That stops me, so I have to head up to the x-axis, and I hit the x-axis at X equals negative 1.
Okay.
Thank you for the question. That's a good one.
Thank you.
There aren't any bad ones, but I appreciate questions. Okay, now it's asking what is the range? And we've got to deal with this same issue that we dealt with the domain. Namely, that just like the graph goes forever to the left and forever to the right, so the domain goes from negative infinity to infinity, which means all real numbers. It's the same thing down here. The graph goes down forever and up forever. Down here, you've got a negative infinity. Up here, you've got a positive infinity. So the graph goes, yeah, it's all real numbers. Which seems a little lame, but that's the answer. And let's see, 3 is the same kind of problem, only it's more concise. Now, 4. 4 is designed to mess you up, and so is 5. Because it's got all of these change points, see? It's got all of these points, and it's trying to draw your attention to them. But what you're being asked is, hey, all I want to know is the domain. That's all I want to know. Let me make this bigger and bigger and bigger. Okay. These are all really nice points. I don't care though. All I want is the domain. And notice that the end points are actually solid. So this end point ends up with negative 5 on the x-axis and positive 5 on the x-axis, which means I'm going to use brackets. And you've got brackets on your keyboard. So here's the left bracket. And I'm going to go to negative 5 right here. Negative 5, and then a comma, and then a positive 5, and then a bracket from my keyboard. And that should be what the domain is, because it doesn't go on forever. It doesn't have arrows here. It has solid dots with nothing coming after or on the outside of those end points. These are the end points. The domain is going to be negative 5 to positive 5, which is, all right, here's how they ask us to write this. Oh, and down here, it says type your answer in interval notation because it's so much easier to type. Okay, now all they're going to do is ask about the range. Okay, all they're going to do is ask about the range. The range is on the y-axis. I go to the lowest point and I see what that y coordinate is. And I go up to the highest point. These are equally high, but that's as high as this gets. And I see what that point is there, what that y value is there. So this is negative 3 on the y-axis, and this is positive 5 on the y-axis. So I'm going to put a bracket, negative 3, comma, and then positive 4 on the y-axis, and a bracket. And that's what I'm going to check and see. Now notice I didn't answer anything. Notice this only goes down to +1 on the y-axis. It doesn't matter because there are other values of x that match up with this and other values of y that match up with this going all the way down to -3. And then there's nothing. There's nothing. So let me check my answer. And then we've got the same thing going on over here. So let's do this real fast. In spite of the fact that you've got all these dots, you've got arrows on the end, which means that this graph is going to go forever to the left and forever to the right. And see how it tips down? It's going to end up going forever down, but it's not going to go forever up. It's just going to stay at the number 5. So here's what we're going to do. Just looking at the domain, which is the left and the right, this graph will go forever to the left and forever to the right. So if I'm answering an interval notation, which is what I'm told to do right there, I can actually use this tool right here and put infinity, negative infinity. So I hit a negative first, then an infinity, and then I click on over here. All right, you're bothering me. Oh, foo on you. Okay. And then infinity. We'll have to fix this. And then I'll start deleting and deleting, and now my answer's correct. I tried to take a shortcut that wasn't a shortcut. So you would type in a parenthesis and a negative infinity, comma, positive infinity, and another parenthesis, because this is going all the way to negative infinity on the left and all the way to positive infinity on the right. In set builder notation, you would write all real numbers, but in interval notation, you would write negative infinity to positive infinity.
Wouldn't
Check
those be in brackets since it's closed?
No, good thinking. But you never put brackets around infinity signs.
Oh, okay.
Another little rule. Now the same, oh, no, not the same thing. This is going to end up, see the way it curves? It's going to end up going down forever. Okay? So this is going to go parenthesis, negative, infinity, comma, but notice as it starts going up, it suddenly stops here at y=4. Y=4 is as high as it goes. And then it goes forever to the right, but these y values never go above y=4. So y=4 is as high as it gets. So I'm going to put a 4 and a bracket. So you have to be really careful sometimes. See if I'm right. Oh, yes. Okay.
Would
Yeah,
you
go ahead.
always
Say it again.
would you always with the negative on that one since it's negative infinity, or can you flip it where it would be 4, comma, negative infinity?
Good thinking. You always put the lowest number or sign before you put the highest number or sign.
Okay.
Very good. More questions. This is confusing. I know. I remember being a student.
So when we are using like infinity signs, we always use parentheses.
Yes, you do for infinity signs, whether it's negative infinity or positive infinity. The
Okay.
reason for that is that negative infinity and positive infinity are not numbers. They're really symbols that means go on forever. So since it's just a symbol, you wouldn't put a bracket around it.
Okay, thank you.
You're welcome. Okay, actually, we only have half an hour to go. I hate to take a break for restarting, so let's try to keep going.
I'm just now getting back on here.
Oh,
It just now restarted. That took 20 minutes. Felt like.
no, we got to do this one. Okay. This one is different. You might be able to remember some of this from Algebra 2, but anyway, you remember back in elementary school when your teacher first taught you about fractions. She said 2/3 is a proper fraction, but 2/0 is undefined. Well, it's still undefined. So the domain cannot have numbers in it that make a number undefined, or a letter undefined, or an expression undefined. Here we have a rational function. That's what it's called. Anything with the word rational in it means fraction. The domain is going to be all the allowable x coordinates. Well, I'll tell you what's not allowed here. 1/0 is undefined. So whatever x makes the denominator, the bottom, undefined, that's a no-no. So 9 minus 5x equals 0 is what we have to stop from happening. So we're going to solve that little equation to find out what x makes 9 minus 5x equals 0.
Are we supposed to be seeing you or the worksheet?
The worksheet.
I see you.
Does everybody just see me?
I
No.
see the worksheet.
I see
No, I
the
can see the
I
worksheet.
see the worksheet.
I don't know what I did.
What you need, I know what you need to do. It's simple, I think. If you hover your mouse over the team symbol down on your taskbar, you should see two pictures. One of me and one of the worksheet.
I see a symbol saying sharing in progress.
Oh dear. I don't know. I don't know. At this point, just kind of, I don't know, try to get in here, but remember this is going to be turned into a video.
Okay.
Okay, so anyway, I have to find out what x equals when 9 minus 5x is 0. So I'm going to use all of those old skills from solving equations. I'm going to add 5x to both sides. Negative 5x plus 5x is 0, which leaves me with a 9 on the left, equals 0 plus 5x is 5x. Then to get x by itself, I divide by 5, I divide by 5, so that the 5s will cancel, and what I end up with is x equals 9/5. This is the number that will cause this to equal 0. So this is bad. And we cannot allow x to equal 9/5. So I put that symbol in there, which means cannot equal. X can equal any number in the universe as long as it's real, but not 9/5. So I come over here to my math lab where I look at all the possible answers. And here I have x is real, x is a real number, and x cannot equal 9/5. Now 1 and 0, look at all the cannot equals. Now from our work that we just did over here, we never said x cannot equal 1 or x cannot equal 0. So you would immediately just not even consider A or C as your answers. So the only answers that have 9/5 in them are B and D. And so let's translate this into words. This is all the x's such that x is a real number and x cannot equal 9/5. Or x such that x is a real number and x is greater than or equal to 9/5. Well, we don't have anything like x is greater than or equal to 9/5. All we got when we calculated this was x cannot equal 9/5. So I'm going with this one, B. And I'll check the answer, and that'll be right. And then we have another one of these. What is y when x is -2? What is y when x is -1? What is y when x is 0? And that just means you look at the x like -2, and you ask yourself, well, what is the y when x is -2? What is the y when x is -1? And they've even put little dots there for you. What is the y when x is 0? And you can do this because we've already just done it. So let us go on to the next set of problems. How do I get out of here? No, that wasn't good. Okay, so function arithmetic. Let's go on to slope first, just to give you a review of slope, and then we can double back to function arithmetic, which I strongly expect we will not get to. Better to just go ahead and review slope. The slope of a line. Up till now, slope has been the slant of a line. Can you see my math lab? Or the fact that I started it and stopped it again, did that mess everything up?
No, we can see it.
We can see it.
Oh, good. Okay. So I'm going to click on question 1. Question 1. There it goes. Whew. Okay, there we go. Here it is over here. And here, let me go to a new slide. Okay. Ooh, now I could make this like this, but then I wouldn't see what they're doing, but I can right now. Find the slope and the y-intercept of this linear equation. And that's 4x minus 8, y equals 60. Now remember, this is a line in standard form. Y equals mx plus b is slope-intercept form, but this is called standard form. They're interchangeable, and I'm about to interchange. Standard and slope intercept. Okay, well, the way we're going to find out what the slope is we are going to manipulate this into this form. And notice that we have the y on the left and the x's and other stuff, technical term, on the right. So notice that the term 4x is positive. The term 8y is negative because it has a negative sign in front of it. To get 4x over to the other side from the y term, I subtract 4x from both sides. Minus 4x. 4x minus 4x is 0, which leaves me with, actually this leaves me with 0 minus 8y, which will be negative 8y. Over here, I could say 60 minus 4x, but we always put the x term first because that's the way you write slope-intercept form. So I'll take the term and its sign, negative 4x. 60 up here is positive 60, so I'll have a plus 60 here. And that's the change I've made so far. Negative 8y equals negative 4x plus 60. Now, all I have to do to solve for y is divide both sides by negative 8, but since this is the equation of a line, I'm going to divide each separate number by negative 8. The negatives cancel. 4 over 8 is 1/2. Meanwhile, over here, the 8s and the negatives cancel. So I'm left with y equals 1/2 x. Now, we're going to make the calculator do the work. Can you see the calculator?
Yes.
Good. Okay, I've got positive 60 over negative 8. I am going to divide 60 divided by, now, it's very important we go over this. Let me see if I can make this bigger. I can't really. TIs have two keys, one for minus, one for negative. Now, because I'm dividing by negative 8, I push this sign down here. So negative 8. Now, I could hit enter, and I'm going to do that, but I need a fraction. So I am going to hit math, frac, which is enter, and then enter again. Negative 15 over 2 is how it reduces, or you can reduce it by hand. So that'll be negative 15 over 2. Now this is slope-intercept form, where the slope is 1/2 and the y-intercept now watch this. All points have two numbers, an x-coordinate, comma, and a y-coordinate. A y-intercept is going to always have a 0 in the x position. So the y-intercept is 0, comma, 15 over 2. So once we have this, we can go back I can go ahead and reduce the size, minimize my calculator, and come back over here and look for the answer box. Where's the answer box? Good grief. Here, answer box. Oh, I have to choose. Solve the given equation for y in order to rewrite the equation in slope-intercept form. Solve the given equation for x in order to rewrite the equation in slope-intercept form. Well, we're solving for y, right? That's why we went to all that trouble, was so we could solve for y and get this into slope-intercept form. You don't solve for x, you solve for y. So A, and I'll click final check. Excellent. Oh, now they're asking me to go step by step. What a pain. Okay. Okay. I want it a little bigger than that. Here's the next question. Notice that we went step by step up here. And now we're going to have to rewrite the steps that we took. The first thing we did was subtract 4x. So the next step we took was negative 4x plus e. And we get that from back up here. Negative 8x equals negative 4x plus 60. And it says do not factor. Okay, I won't. And now I'm being told, okay, meaning it's what we were supposed to do. And now it wants me to solve for y. So instead of dividing each term individually by negative 8, they took them both together and did it. Look, and we didn't have to turn the terms around either, but I say you do. Negative 8 well done. Okay, now. So what is this going to equal? This must be the end, right? I don't know what they're looking for. Use integers or fractions for any numbers in the expression. It's not the last question, though. This has me worried, gang. All right, if I type our answer, 1/2 x minus 15 over 2, what will happen to me? I don't know. I'm going to take the fraction tool, put a 1 on top, a 2 on the bottom. No, that's not on the bottom. Down here, down here, down here, down here. Well, the heck with you. Let's just say 1 divided by 2. Okay. Now, I have to hit the right arrow key on my keyboard. And you can't see my keyboard. So just hit the right arrow key so you can come out to the end. So now the cursor is out here. And then minus, I think this is going to be wrong, by the way, 15 over 2.
Miss Barbara, you forgot the X on the
Oh,
1
you're
over 2.
right. You're right. You're right. Thank you. Why is this giving me such trouble? Why? Minus 15 divided by it called it right. See what I get for trying to read the mind of the computer. Okay, for an equation in the form y equals mx plus b, something is the slope, M is the slope, and B is the y-intercept. That's in the formula. And more questions. Good grief. Therefore, the slope of 4x minus 8y equals 60 is 1/2. And the y-intercept is 0, comma, negative 15/2. Yes. Oops. Wait a minute, you come back here. So this is what we have right here. Let's make this big. They're actually taking us through all of the steps. So maybe there wasn't even any need to write anything down. I think there was. And this is if you did every step, what would those steps be? This is how you would get your answers. And there are a few of these that actually take you step by step through it. And I had forgotten that I put this in. Okay, here you're just being asked, well, which number is the slope and what's the y-intercept? The slope is 4. Okay, we could check answer. Can we check answer? Yes. Check answer. Good. And the y-intercept is 10, so I put the 10 here since they already have 0, comma, and parentheses. You always have to have parentheses around points. Okay. Don't worry, it gets more interesting. All right, here they're asking us to do this business again. Let's move on. All right, find the slope. This is interesting. All right, there are 2 ways we can find the slope of the line, but one of the more interesting ways to find the slope of the line is to make a little triangle between these 2 points. Imagine making this into a right triangle, where this is the height of the triangle, and this is the base of the triangle. So this is the base, and this is the height. If I count down the height, it would be 1, 2, 3. So the height is 3, right? And if I count the number of units in the base, it would be 1, 2. So we could say that the base is 2 units long and the height is 3 units high. The slope of any line is the ratio, the fraction you get when you put the height on the top and the base on the bottom. So that since the height is 3 and the base is 2, I come over here and I type 3/2. And that's my base. I mean, that's my slope.
Miss Barbara, I have a question.
Yes.
Are they always gonna be 2 points so that you can get the slope of the line, or?
Yes. That's all you need is 2 points.
All right.
A third one would get in the way. Okay, let's check our answer. Very good, but let's look at the normal way to do this. This is the way everybody knows and hates. slope. Calculating the slope. Remember the formula for slope? M for slope equals y2 minus y1 over x2 minus x1. Now, x1 and y1 are the coordinates of your first point. Well, let me make that neater. X1, Y1, that's the first point, that's point 1, and X2, Y2 is point 2. How do you know what point 1 is and point 2 is? It does not matter. You just have to be consistent once you choose. Okay, so I've got the 0.53. Since that comes first, I might as well, because it doesn't matter, make this x1, 1, y1. And then I've got the 0.107. And that's x2, y2. So now I'm going to put this, since we have, I could actually go to one more step and say, okay, x1 is 5, y1 is 3, x2 is 10, y2 is 7. And then put them in the slope formula over here. M equals 7 minus 3, y2 minus y1 over x2, which is 10, minus x1, which is 5. Let's make sure. 7 minus 3, yes. 10 minus 5, yes. That will be 4 over 5. So this is that slope over there of the line, of the whole line that goes through these 2 points, 5, 3 and 10, 7. And it doesn't matter. Doggone it. Wow, it's giving me trouble today. Fine. 4 divided by 5. There. And I check my answer. And there you go. Okay, it's 10:49, which means in 1 minute it's 10:50. We did not have time to do this, but I am going to go through and do all the homework problems for you. How about that? Neatly with notes. So that in a day, by tomorrow, you'll have them. You'll also have the video in, I don't know, an hour or 2. It's pretty long. I thought I had stopped it and started it again, but I have this fear it just went on and on and on. But we'll see. We'll see what happens. If it's 2 videos, I will be happy. But anyway, okay. For those of you who have to leave at 10:50, class is over. But I have no pressing social engagements, so I'm glad to just sit here and answer questions.
So, I have a question about the homework. So,
Yes.
I'm not sure how you do it, but like my instructor last semester, she let us like do our homework. She like let us wait till like the end of the semester. Like she graded it like as time went by, but we were able to take like as long as we needed for the homework, or do you grade it like the day it's due and then that's it?
No, I'm not that mean.
Okay.
You've got until, I guess, next Friday night,
Okay. So the day that is
because then we have class on Saturday.
okay. So is the day that is on the homework the day that it's due exactly, or is that the day like that you assign it? Because I know some days have like 23rd, 24th, 25th, like.
I'm
Yeah,
just trying to
says-
spread it out for you. My math lab does better
Mhm.
when you do each assignment on a different day. So I was just kind of filling up the week and trying to, give the message that you could take the whole week.
Okay. Okay. Then.
So you're saying even if it says it's due on the 24th, I still have the whole week?
Yeah, up until next Friday, which is what? Well, I could look. I have a calendar.
It's the 28th.
28th.
So
Yes.
basically, it'll be due the day before our Saturday morning class. So we have till Friday before the Saturday morning class to turn it in. Or have
Right,
it
Friday
in.
at 11:59.
Okay, so every Friday.
Yes.
Okay.
But not everyone will be done with it. Also, I have to show you something. Don't leave yet. Well, it's too late. If you go to any homework assignment, and you click in the upper right-hand corner where it says question helps, if you have a question about a particular problem, the best way for me to see what your problem is for you to go to question helps for that problem, come down to ask my instructor, and that's an email that goes right to me, but it sends a link with it so that I can actually see what the problem is.
Okay.
Okay, thank you.
You're welcome. And then we can
Yes.
we can share on it in person or by email, whatever you like. Also, if you go to Canvas and you go to where it has your profile
Yes.
and you go to notifications, you can choose to be notified in your email or by text. When things are due, or when you notice, what am I trying to say? To be notified by text, like if I send you an email, it might go to you by text, or you might get a notification by text that your teacher just emailed you, something like that.
Yep.
So it's a pretty good deal. And there's a Canvas app that's free for iPhone and for Android. And most of my students swear by it. Most of them do all their Canvas work, like discussions. We have a discussion due on Wednesday. It's not hard. It's not a math discussion. It's about all the changes that are going on and what you're doing to cope with it all emotionally. Because I'm finding it hard as a teacher, quite honestly. It's stressful. So yeah, just to talk about the stress. I try not to get mathematical in the discussions, because when I do, all the people leave and then nobody participates. So I've learned, okay, I won't ask anything mathematical in the discussions.
I have a question, and I don't know if I missed this at the beginning of class while I was trying to get connected. Will you go over a little bit about the grading process and where, is my math lab, the grade that we see on there, going to be what we would consider our running grade until
Yes.
we test, and then the final?
Yes, your actual grade is in Canvas.
Okay.
So you'll be able to see your grade 24/7. Anytime you go into grades, assuming that my math lab is working, and it almost always is. It's a lot better than the NWAC system, or my math lab. Yeah, you're able to see your grade anytime you want to see your grade.
Okay, and this might be in the syllabus also, that if we.
Yes, it is.
Okay,
Yes, it is.
Okay, got it. Thank you.
With the quizzes and the exams, are we gonna be able to show work to get partial?
On the exams, yes. I was going to mention this closer to the exam, which is the 5th week. But yes, there'll be a place where you can scan or take photos of your calculations, your scratch work, and upload them so I can look at them and give you more points.
And that's for the quizzes and the exams?
The exams, not the quizzes. You still have the all of the question helps in the quizzes, because the quizzes are just practice exams.
Okay. Okay.
And
Okay.
So on the grading, when it says week 1 notes, is that going to be like what we took as notes?
No, I'm going to upload those.
Well, it has it in the grades. I might be misunderstanding because it says like to submit something week 1 notes.
Oh, okay. I haven't looked at it yet.
Okay.
Okay. That was just designed to give you a point. It's for 1 point.
Okay. Yes, ma'am. Yes.
It's for 1 point, and it's if you get a point if you look at the videos I've uploaded, and I've already uploaded the introduction to the class.
Okay.
And you might find it very helpful to go ahead and look at the videos. The first one is the video I sent out last night about all about the syllabus. And the second one is the basic functions of the TI calculator. The TI-83 and the 84 and the 84 CE, they all do the same things.
That's awesome.
So this is just like the basic stuff, but so you can get familiar with it.
Okay. And I accidentally went into the how to work my math lab, and then it like kicked back to score, and I wasn't done. Can I still just
To my
proceed with
knowledge,
that?
yes. And if anything prevents you, let me know and I'll make sure you can get back in.
Yes, ma'am.
In fact, quizzes you can do over and over again too. And exams you can do twice if you want to. You got to do it once, but if you're not happy with your grade, you can do it again to get a bigger grade, higher grade.
Okay.
And then my math lab uses whichever grade is higher to calculate your score. It doesn't average the scores.
Okay.
Okay, I might be repeating the same question I just asked earlier, but I just want to double check. So I have my math lab open. So
Yes.
all the homework that's due before the 29th can be due before that Friday. It doesn't have to be the exact days, right?
Oh, no, you can go as fast as you want. In fact, you can go ahead and get done with the whole term if you want.
Okay, but just like the ones that like are due like the 24th, like if I don't do it, like if I do it the 26th, it wouldn't count as late and I'll still be able to do
No, no. And now it'll say on my math lab, it'll say past due,
it.
but it's not really. Don't pay attention to it.
Okay.
It lies.
Okay, because I know sometimes like it won't, like if it's past due, it won't let you go back and do it. If it's past due, like we'll have to let you know to like open it up again.
Yes, yes. But that's up to me. And I pretty much know that time is a problem. Most of you work. Most of you have kids. I mean, you have a lot of stuff going on in your life. I have a lot of stuff too. So I try to be as lenient as I can.
And it doesn't say on there how many attempts it has to do the homework. Do you know
Oh, infinite.
how? Okay. Okay.
Infinite. Yeah.
Okay. Just making sure.
If you can plug infinite into a week, yeah, that'd be great. You break a record. Actually, it's not going to disappear at all. but you
Okay.
want to try to get it done before we pick up something else.
Yeah, I learned that the hard way.
And Miss Barbara, you said that you would be available at what time?
Oh, Monday, Tuesday, Wednesday, Thursday, 3 to 6,
3 to 6.
and 7 to 9. But I mean that's just a ballpark thing. You can make an appointment. I
Okay.
do have to teach in the mornings. My mornings are almost completely taken up with teaching. But in the afternoons, I'm pretty free.
So
Okay.
are you on campus also, or are you just doing online?
Online.
Okay.
So if we schedule an appointment with you, how is the appointment handled? Is it on the phone or?
No, not on the phone. I hate phones.
Okay.
Yeah, it's just me. Um, uh, if you want to talk face to face, we can do it here on the computer.
Okay. Okay.
And then there's also a Microsoft Teams app you can download to your phone, so you can do it on your phone that way.
Okay. Good. Good.
But you can't take the tests on your phone.
Right. Okay.
Okay. All right.
Well, thank you very much. I appreciate all the information that you've given
Yeah.
us. What you
Thank
taught.
you. Have a good day.
Oh,
Thank
yes,
you.
I will, but I'm still here if anybody's got other questions.
How do I get off, AJ?
Anybody got other questions? You can go ahead and leave if you're done. Email me if anything comes to mind that you want to ask about.
I just have a little question. If we
Sure.
have mistakes on like some of the problems with like even though we can try again, will that affect our score or not?
No, no.
Oh, okay.
Yeah,
Thank you.
it's sort of a win-win. No, you
Okay.
can make the computer think you've got all 100%.
Okay. Thank you.
You're welcome.
Thank you. Bye.
Thank you.
Bye, but I wasn't saying you have to go away. Does anybody have any more questions? That's all. I want to answer all your questions, especially on the first day.
Everything's fine here.
Okay, great. Email me if you have questions,
Thank
Okay.
you.
or come to my office hours if you have questions.
Thank
Okay.
you.
Thank you. Bye.
Bye-bye. Cool. I guess I'll stop recording.